Engine Fundamentals. The Engine Fundamentals section of the ASE certification test focuses on evaluating your knowledge of automotive engine systems, components, and designs. This lesson will provide an in-depth understanding of the essential components of an engine and how they function together to power a vehicle. We will also explore the different types of engine designs, such as inline, V-type, and flat engines, and discuss how these designs affect performance and vehicle application. Understanding engine components and systems. Automotive engines are complex systems made up of various components that work together to convert fuel into power. Understanding these components is crucial for diagnosing engine problems and maintaining engine performance. Key engine components. Cylinder block. The cylinder block forms the foundation of the engine, housing the cylinders and supporting various engine components, such as the pistons, crankshaft, and camshaft. Pistons. Pistons are cylindrical components that move up and down within the cylinders. They play a key role in compressing the air-fuel mixture and transferring force to the crankshaft during combustion. Crankshaft. The crankshaft converts the up and down motion of the pistons into rotational motion, which is then transmitted to the wheels through the drivetrain. Camshaft. The camshaft controls the opening and closing of the intake and exhaust valves, which regulate the flow of air and exhaust gases in and out of the engine. Valves. The intake and exhaust valves allow air and fuel to enter the combustion chamber and exhaust gases to exit. They are operated by the camshaft and are critical for efficient engine performance. Connecting rods. Connecting rods link the pistons to the crankshaft, transferring the energy generated by the combustion process to the crankshaft. Timing belts chain. The timing belt or chain synchronizes the movement of the crankshaft and camshaft to ensure the proper timing of the opening and closing of the valves. Cylinder head. The cylinder head contains the intake and exhaust valves, the camshaft, and the combustion chambers. It is bolted to the top of the cylinder block. Oil pan. The oil pan holds the engine oil, which lubricates the moving parts of the engine, reducing friction and preventing wear. How these components work together. Combustion process. When fuel is injected into the cylinder, it is compressed by the piston. A spark from the spark plug ignites the fuel-air mixture, causing combustion. The expanding gases push the piston downward, turning the crankshaft and generating power. Power transfer. The crankshaft's rotational motion is transferred to the transmission, which ultimately drives the wheels of the vehicle. Types of engine designs. Engine designs have a significant impact on vehicle performance, efficiency, and suitability for different applications. The most common engine designs are inline, V-type, and flat engines. Inline engines. Design. In an inline engine, all the cylinders are arranged in a straight line along the length of the engine. Common usage. Inline engines are commonly found in smaller vehicles, such as compact cars, sedans, and light trucks. Advantages. Compact design. Inline engines are easier and cheaper to manufacture. Smooth operation. These engines generally offer a smooth and reliable performance, especially in four-cylinder configurations. Example. The inline-4 engine is one of the most common engine configurations found in passenger vehicles. V-type engines. Design. In a V-type engine, the cylinders are arranged in two banks, forming a V shape. This configuration allows for a more compact engine design compared to inline engines. Common usage. V-type engines are used in larger vehicles, such as trucks, SUVs, and performance cars. Advantages. Powerful performance. V-type engines, such as V6 and V8 engines, provide higher power output, making them ideal for vehicles that require more horsepower and torque. Compactness. V-type engines are more compact than inline engines with the same number of cylinders, allowing for better weight distribution in vehicles. Example. The V8 engine is commonly used in trucks and high-performance sports cars. Flat engines. Design. In a flat engine, also called a boxer engine, the cylinders are arranged horizontally in two opposing banks, creating a flat design. This configuration provides a low center of gravity, enhancing vehicle stability. Common usage. Flat engines are often used in sports cars and performance vehicles. Advantages: low center of gravity. The flat engine's design improves the handling and stability of the vehicle. Smooth operation. Flat engines are known for their smooth operation due to the opposing cylinders balancing each other out. Example: the Subaru Boxer engine and Porsche 911 use flat engines. Comparing engine designs. Here's a table comparing each engine design. I'll give you a few seconds to review the table. Conclusion and recap. In this lesson, we covered the essential components of an engine and how they work together to power a vehicle. We also explored different engine designs, including inline, V-type, and flat engines, and compared their advantages and applications. Understanding these engine fundamentals is key to your success on the ASE certification test and essential for anyone pursuing a career in automotive